Hey, this is Joe at Graybench Electronics. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Moog MF Drive. Alright, here's the MF Drive from Moog, from the Minifooger series. We already looked at one of the other pedals from the series, the MF Boost. This is the drive pedal, which after their discontinuation about 2 years ago or so, the price of these has risen pretty steadily. I'm expecting the internal construction to be pretty similar to the Boost, but of course we do have different features. This is a drive pedal, so you're going to expect to get more distortion out of it. We also have two switches inside here versus the one on the Boost pedal. There is a drive switch that when you turn it on, it gives you extra distortion, and a peak switch, which affects the tone and filter controls and how they interact with each other, and also the severity, essentially. Interesting thing about this pedal is it has built into it one of the key components or key features of Moog synthesizers, which is the Moog transistor ladder filter. Potentially one of the most important inventions in electronic music history, because it allowed Moog to create a filter that was simple and low parts count and readily available components, so that they can integrate most of them into their sort of console synthesizers. And apparently this pedal also has one of those transistor ladder filters built into it. The gain stages are made up of one or two transistor conductor amplifiers, the LM13700, and we'll look at that in a second. And otherwise, it's just a nicely built pedal, and it's also one of my personal favorite drive pedals. I've always liked the sound of these. They always have a ton of tonal options with both the tone and the filter control. And you also have this interesting feature where there's an expression control that lets you sweep the filter back and forth, and you effectively get like a wah pedal out of this as well. So there's a lot of versatility in this drive pedal, and it can, in my opinion, replace probably 2 or 3 drive pedals that might already be on your board. It's unfortunate that they're discontinued, and there's not really anybody making a PCB out there as far as I know, although I've spoken to a couple people and there may be something in the works sometime in the future, so hopefully that is the case. For right now, let's go ahead and look at this pedal. So we have a custom-made die-cast enclosure Moog had made for these pedals. Back door is probably just steel sheet metal. We've got the information here. They're made in, or were made in, North Carolina. Serial number, Moog logo, power input information, 9 volts, center negative, standard. According to this, 12 milliamps of current draw, which is actually kind of a lot for an overdrive pedal that doesn't have any digital stuff going on. Input and output jacks and DC jack and expression pedal are all top mounted. The MF Drive little plaque here is riveted on, which I think I pointed out in the Boost pedal is just a nice touch. They could have just used adhesive and just stuck it on. Similar to the way essentially this banner here, all this stuff with the jack labels and the potentiometer labels, switch labels, this is just a sticker that's put into a little recess in the casting, but the little name placard here is riveted on. Foot switch feels like a standard latching foot switch, but as we'll see in a second, it's not a 3-pole double throw, it's a double-pole double throw. Back door here is held on with little rubber feet that have the mounting screws inside of them. I mentioned it before in other pedals that I don't like the rubber feet with the screw going inside because there's no definitive stop for the screw. And so you can sort of just blow through the rubber. If you just keep tightening it, you'll just pull through the rubber. The one added benefit, though, is that you essentially have thumb screws because the rubber, it's easy to grip and it bites onto the screws, so you can undo the screws by hand, which is nice for a pedal like this where it has a battery, a 9-volt battery receptacle inside. So that is it for the exterior of the pedal. Let's go ahead and take it apart, have a look inside. All right, so here's the MF Drive taken apart. First off, the enclosure, like I said, it's a custom die-cast enclosure they had made for the series here. Looks like this one at some point had some battery leakage. Let's just go ahead and clean that up real quick. Okay, that's better. So the enclosure has some structural supports here that increase the rigidity of the enclosure, just so when you're stepping on it, or if you step hard, it doesn't crush the enclosure. It does also have a 9-volt receptacle built into it, so you can see these two tabs here on the PCB, and they're marked positive and negative. They will line up to this little notch on the aluminum piece here, like so. And so that will be in there touching that. And then on the back of the door, there's a little piece of foam that pushes down, make sure that the 9-volt doesn't rattle around. The enclosure has a little stud here, a little part of the enclosure that's jutting out and allowed to connect to the PCB via a screw terminal. So that's this little screw here. And that will give continuity between the ground and the circuit and the enclosure for interference rejection. Normally you do that through the 1/4-inch jacks, but you can see here these have plastic sleeves, and so that won't connect to the enclosure, so that's how they're grounding the circuit. They're connecting via a little screw terminal there. The other screw terminal is just for structural support, and that's just a little plastic standoff connected to between the two PCBs. And then same thing we saw on the MF Boost, the casting actually has little notches that are cast into it that meet up to the little anti-rotation tabs on the potentiometers that are being used for the pedal. Not sure if that's particularly necessary. These potentiometers do have 5 solder connections each to the board, but it's a nice little touch. And that's pretty much it. You can see the end of the rivets for the front placard there, just little pop rivets. So that's it for the enclosure. Now onto the PCB. So it's a dual PCB design here. We have the top board, which handles presumably all the switching and the input and output, and also the power supply. We've got a bunch of little 3-pin packages here that are most likely diodes because they are marked D. There are some marked Q, like Q1, Q2, but these ones D3, D4, or D5 and D4 here, these are diodes, like dual diodes. The 8-pin dip package here is marked 33178. We already looked at the battery terminals that are soldered into the board. D2 up here is most likely a polarity protection diode. And then we have our 1/4-inch jacks, which are the input and output and expression in the middle, and then our DC jack. Over here the writing says up and down the ladder again, so that's probably referring to the transistor ladder. And this is marked September 11th, 2013, Moog Music, Inc. As far as components, it's all surface mount. We do have one through-hole capacitor and a big surface mount cap here. It's a 470 microfarad cap there. And then this little header pin socket there matches up to the foot switch little assembly here. And like I said, this is a double pole, double throw foot switch, and that is because this pedal uses the a Millennium bypass, which is like a bypassing with a MOSFET transistor. So flipping over to the second PCB, this is where the actual pedal circuit is. So right here we have the should be LM13700 transconductance amplifier. In the middle here, this is the transistor bridge. So these little black packages and the surface mount film caps in between. These little packages here are dual transistors. So 1, 2, 3, 4, 5. Those are 2 sets of transistors, and then the film caps are in between them. And you can see that if you look at the a schematic for the transistor ladder filter, that's what it looks like. And then we've just got all the associated components. We've got another little transistor up here, down here, another one here, and then a bunch of caps, all floated in resistors, all surface mount. The potentiometers, as far as values, the gain pot here is a linear 100K. The output is a audio 25K. The tone is a linear 100K. And the filter is a linear 25K. And then we've got the high and low gain switch marked there on the board. And then here's our peak switch soldered onto the board. LED down here. The 2 boards here are connected with this ribbon cable, a 12 contact ribbon cable. And from what I've read, they can be pretty fragile. So if you're ever taking apart yours, just be careful of that. There is some silicone caulk placed on there to try to provide some strain relief for the ribbon cable, so that's nice. And then on the back side of the top PCB, we do have a little tag here. It says 10/11/2013. So this is probably the date of manufacturer or the date of the quality check. So October 11th, 2013. So that is it for the MF drive from Moog. Let's go ahead and put it back together. All right, that's it for the teardown on the MF Drive from Moog. If you have any questions or recommendations for a pedal you want to see on an upcoming teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing. I am Joe from Graybench Electronics. Thanks for watching.